Welcome. In this video, I would like to introduce you the simulation program XTAP for the analysis of electromagnetic transients in power systems. The program XTAP is available to everyone for free of charge. It can be downloaded from the website at www.xtap.org, shown at the right bottom corner of this slide. I am Takunoda from Central Research Institute of Electric Power Industry. Okay, before talking about XTAP, let's take a look at what are power system simulations. This figure organizes various kinds of power system simulations in terms of the order of the time scales of phenomena occurring in power systems. The horizontal axis shows the time scale conceptually. If you go to the left-hand side, faster phenomena are shown. The right-hand side shows slower or finally steady-state phenomena. Three major categories are shown by red, green, and blue circles. The blue circle on the right shows steady-state simulations, the slowest simulations. Positive sequence or single-phase circuit equations are formulated, assuming balanced three phases, and their Phasor solutions, in other words j-omega solutions, are obtained. Power flow, fault, voltage stability, and small signal stability simulations are included in this category. The green circle in the middle shows Phasor simulations, or often known as transient stability simulations. Also, positive sequence circuit equations are formulated, and their Phasor solutions are successively obtained as time progresses. So, what we get is time variations of Phasor voltages and currents. It covers a time scale from about 1 second to minutes, and sometimes to hours. This category includes transient stability simulations and also frequency stability simulations. The red circle on the left shows electromagnetic transient or EMT simulations. Now, three-phase circuit equations are formulated taking all small impedance imbalances and mutual couplings among phases into account, and their waveform levels solutions are successively obtained as time progresses. So what we get is waveforms of voltages and currents at various points in the power system. Traditionally, it covers a time scale from sub-microseconds to tens of seconds. Thanks to enormous progress of computers, now it is possible to use an EMT simulation program to simulate up to hundreds of seconds. XTAP is a simulation program for this category. The category includes various kinds of simulations such as overvoltage simulations and power electronics converter simulations, and I will mention the details of applications later using a different slide. Okay, let's look closer at the difference between the EMT simulation and the Phasor simulation. The EMT simulation calculates voltage and current waveforms actually occurring in a power system. As shown in the upper figure, when a line to ground fault occurs on phase B, the voltage waveform of the phase B becomes very small, and transient overvoltages are observed on the sound phases, phases A and C, including surge voltages and temporary overvoltages. Since the EMT simulation gives detailed waveforms of all phases, momentary overvoltage and current values are obtained. It is suitable for detailed simulations of a particular part of a power system. The Phasor simulation calculates time variations of 50 or 60 Hz voltage and current phasors in a power system. Since balanced three phases are assumed, the phenomenon is represented by positive sequence voltages and currents. In the lower figure, a symmetrical three-phase line-to-ground fault occurs, and a voltage drop and a subsequent generator swing is observed. The Phasor simulation traces the variations of the magnitudes and the phase angles of positive sequence voltages and currents and ignores their momentary variations. It is suitable for simulations of a large power system. Finally, notice the difference of the timescale of the EMT simulation and that of the Phasor simulation. This screenshot shows how XTAP looks like. This is actually the schematic editor of XTAP, in which you can draw your power system consisting of electrical circuits and control systems. Then you can perform a simulation. XTAP is equipped with a variety of simulation models necessary for various kinds of power system simulations in the parts box on the left-hand side. So, XTAP is an industrial-grade EMT or waveform level simulation program which is available to everyone for free of charge. XTAP is also equipped with a waveform plotting tool called XPlot. XPlot has various useful functions such as Fourier transform and Fourier series calculations and other calculations in addition to fundamental functions like magnification, measuring, and so on. XTAP comes with a line cable constants calculation tool called XTLC. XTLC has a database of wires and cables used for transmission and distribution lines. Their dimensions and material constants are already in the database. XTLC calculates line constants of overhead lines and underground cables and is able to produce pi equivalents, constant parameter line models, and frequency-dependent line models. XTAP has an automated consecutive simulation function which allows you to perform the same simulation with different parameter values automatically. It also has a statistical simulation function for simulations with statistical phenomena such as statistical treatment of turn-on timings of circuit breakers in overvoltage simulations. It may be noted that the PV panel model has a tool to determine its power versus voltage and current versus voltage curves from spec sheet data. This slide shows components and models included in XTAP. XTAP has comprehensive electrical and control components which are necessary to build practical simulation cases and user-defined models. It has synchronous generator models with saturation and torsional dynamics. If you enable the torsional dynamics option, then you can use it for subsynchronous resonance studies too. XTAP has various kinds of line models: pi equivalent model, constant parameter line model, and frequency-dependent line model. The parameters of those models can be generated by XTLC. We also have various transformer models: 2-winding, 3-winding, and auto transformer models. We have HVDC and FACTS power electronics converter models, line commuted, PWM and MMC AC-DC converter models, and SVC and STATCOM models are available. XTAP includes photovoltaic PV power generation models. A PV panel model generates electricity from solar irradiation, and PCS models convert the DC power to AC power. A single-phase PCS model is used for representing rooftop systems, and a three-phase PCS model is for solar farm systems. Using those models, you can create your own models. They are called user-defined models. You can even draw your own icons for your own models. Finally, I would like to talk about the DLL-Defined Blocks. For instance, a manufacturer can write CC++ or Fortran code to represent their control block. Then, the manufacturer can compile it to a DLL or dynamic link library, and the DLL-defined block can be used in XTAP simulations. In this way, you can use the same code for a real system and also for a simulation. I believe it can be used by universities too. Applications of XTAP. XTAP can be used not only for traditional EMT simulations, but also for new simulation needs. The simulation of abnormal overvoltages, currents, and oscillations are typical traditional EMT simulations. They include lightning, switching, and black start overvoltages, transformer and induction motor generator in rush currents, ferroresonance and subsynchronous resonance. One of the new simulation needs is power quality assessments, which include harmonics, flicker, and voltage interruptions, drops, swells. Another new simulation need is performance studies of power electronics converters. They include HVDC systems, fax devices, power electronics converters used in renewable energy generation systems, that is PV and wind, and battery storage systems including EVs, electric vehicles. They are very important for developing smarter grids. Now let's talk about the accuracy of XTAP. The numerical oscillation has been an important issue in the EMT community. It is a fictitious oscillation that does not exist in reality, and thus it was a source of error when the traditional trapezoidal method is used for the numerical integration of EMT simulations. XTAP uses the 2S dark method for numerical integration. It is mathematically guaranteed that the 2S dark method never produces fictitious numerical oscillation due to sudden changes of inductor currents and capacitor voltages, unlike the trapezoidal method used in other programs. The figure shows a comparison between the 2S dark and trapezoidal method. A current source controlled by a control system injects a current into an inductor. The 2S dark method does not generate numerical oscillation, while the trapezoidal method, even with a critical damping adjustment, CDA, generates numerical oscillation. So, XTAP is advantageous when it is used for simulations including power electronics converters. We have a very strong research base. XTAP has been developed with incorporating recent research results obtained at Central Research Institute of Electric Power Industry, CREEPI. The primary research results are listed here. We do have a good user community. In Japan, all transmission and distribution companies use XTAP as their standard EMT simulation program, and major manufacturers, engineering companies, universities, and research institutes form a user community. The total number of users is more than 3,300 as of September 2021, and its breakdown into organization types is shown by the pie chart. We also have a good development environment. All transmission and distribution companies in Japan financially support the development, and our institute performs the development project. Education opportunities. XTAP comes with a 178-page manual and 42 introductory and practical test cases for self-learning. A summary of XTAP is given in the IET book shown below. Every year, courses by EMT specialists of our institute are offered in Japan. English online courses can be arranged upon request. Finally, the website of XTAP is at www.xtap.org. XTAP is available to everyone for free of charge and can be downloaded from this site. Other information can also be obtained from this site. Thank you very much for watching this video. Bye now.